Hello everyone. For today's video, we will discuss about multiplication of radicals. Now from the word itself, radical in mathematics is an expression having square root, cube root, fourth root, or any other radical figure having indices. An example of a radical figure or radical expression is square root of x. And this is understandable that square root of x is having an index of 2. Now 2 is what we call index. This sign or symbol here is what we called radical sign or square root. And the one inside the radical is what we call radicand. And the whole thing is our radical expression. So if I have here square root of x, understandable that our index here is 2 because you may not need to write your index 2. And so if you have here cube root of x, understandable that your index here is 3. And if you have here fourth root of x, understandable that your index here is 4. Now we know that when you say square root of x, this is equal to an exponential expression, x raised to the power of 1/2. And so if you have here cube root of x, this is understandable that your x here is raised to the power of 1/3. And fourth root of x is understandable that you have x raised to the power of 1/4. So if you have here fifth root of x, what do you think is the corresponding exponential expression or exponential figure? That is x raised to the power of 1/5. That is all about radical expression. Now, our goal this time is to multiply radicals. So for example, if I have here square root of 2x cubed times square root of 8x y to the 5th, then we are actually having two radical expressions being separated by multiplication operation. And so we have to multiply. So when you are multiplying radicals, make sure that the index are the same, such that according to one of the rules in the radical, if you have n square root of x times n square root of y, if they are having the same indices, then we can copy the index and then we can multiply the radicands x and y. And this is what we're going to do here. So this is understandable that we will be using the same radical sign having the same index of 2. So this is now 2 times 8. You have here 16. X cubed times x. This is now x to the 4th. And according to the rule, if you are adding variables, okay, you have to add your exponent provided that the variables are the same. And then copying y raised to the power of 5. And so we know that when we say 16, this is a perfect square which can be written as 4 squared. And so x to the 4th can be written as x squared times x squared. And that y to the 5th can be written as y squared times the y. Meaning to say, if you will try to add 2 plus 2, it's x to the 4th, and then 2 plus 2 plus 1, it's y to the 5th. Why we are doing this way? So that we can let 4x and y out from your radicand. Because according to one of the rules in the radicals. If you have here n square root of x raised to the power of n, then this is equal to x, meaning to say you can cancel the nth root and an exponent of n. For example, if I have here fourth root of x raised to the power of 4, then it means to say that this radicand x to the fourth is raised to the power of 1 over 4. And so in that case, when you multiply the exponent, this is now 4 over 4 or 1. In short, this is just x. Okay? So therefore, when you are canceling fourth root and exponent to 4, that is equivalent to an x. And this is what we're going to do here. So letting out 4 from the radicand, and we have also 2 x's, so it means that we have x squared. And then 2 y's, meaning to say you have y squared. And that what remains here is the y. Another example, how about if you are having radicals which are having a different index, just like for example this one. Now in this case, the index for our first radical expression is 2, the index here is 3, and the index here is 4, and so we are not allowed to multiply 3 directly, because according to the rule, make sure that your indices are the same for you to multiply radical expressions. Now in this case, we know that square root of x is equivalent to x raised to the power of 1/2. The second radicand 18 is understandable that you have an exponent of 1/3, and the third radicand is understandable that you have an exponent of 1 over 4. Now for us to have the same index, why don't we raise this expression to 12 over 12? Anyway, 12 over 12 is still 1, and we are going back to the original radical expression. Now, why are we doing like this? Because 12 over 12 is understandable that this is equivalent to 12 times 1 over 12. And so if you have x raised to the power of 1 over 12, this is just equal to 12 root of x. And this is what we're going to do here. So in this case, 1 over 12, this is now understandable that this is now 12 root of 6 raised to the power of 1/2, 18 raised to the power of 1/3, and 24, which is now raised to the power of 1/4. And take note that this is still being powered to 12 because we have remaining 12 here. So according to the rule, one of the rules in exponential, one of the properties, we have to distribute our exponent 12 to every exponent here. So this is now 12 root of 6. 1/2 times 12, understandable that this is 12 over 2 or 6. And then 1/3 times 12, 12 over 3, that's 4. And then 1/4 times 12, this is 12 over 4 or raised to the power of 3. Now in this case, all we have to do here is to get the prime factorization of 6. Okay, so when you say 6, this is equivalent to 2 times 3. So we can replace 6 as 2 times 3 raised to the power of 6. And then 18 can be written as 2 times 9, and then 9 can be written as 3 times 3. So you have 2 times 3 times 3, or this is now 2 times 3 raised to the power of 2. And don't forget that you have an original exponent of 4. And then when it comes to 24, we know that 24 can be written as 2 times 12, but 12 can be written as 2 times 6, but 6 can be written as 2 times 3. So you have 2 times 2 times 2 times 3, or this is 2 to the 3 times 3 raised to the power of 3. Do not forget your exponent. Now, why are we doing like this? This is for us to combine all exponential figures having a base of 2 and all exponential figures having a base of 3, which means that this can be now filtered into 2. Now, if you will be focusing on 2, then that is 2 to the 6, because this is understandable that this first exponential expression will be 2 to the 6 times 3 to the 6, or it has an exponent of 6. So when you will try to look at the second expression, this is 2 raised to the power of 4, so you have to add. And then 3 times 3, it's 9, so you have to add also here. And so this is now 3. And then understandable that it has an exponent of 6. 3, 2 times 4, that's 8, so meaning to say you have to add 8. And then 3 to the 3, or which is 3, plus 3. So in that case, we are now ready to simplify our exponents right here. Okay, continuation here. We have now the 12th root of 2. 6 plus 4, that's 10 plus 9, so this is now 2 raised to the power of 19. And then 6 plus 8, that's 14 plus 3, so that's 17. So 3 raised to the power of 17. Now, make sure that in a radical expression, your index must be greater than the exponent of your radicand. And so we can write this one as 12 root of 2 raised to the power of 12 times 2 raised to the power of 7. Because if you will add 12 plus 7, it's 19. And then times, do not forget your 3 raised to the power of 12 times 3 raised to the power of 5. Because 12 plus 5 is 17. Now, why are we having it factored as 12, 7, and 12, and 5? So that we can let 2 and 3 out from your radicand. And so in this case, it follows from our index. So let 2 and 3 out. And so this is now the 12th root. 2 times 3, we're letting out 2 to the 12 and 3 to the 12 out because this is being cancelled. And so what's left is our base 2 and 3. And so this is now 12 root of 2 raised to the power of 7, the remaining one. And then this is 3 raised to the power of 5. And so simplify 2 times 3, it's 6 12th root of 2 raised to the power of 7 and 3 raised to the power of 5. So we are satisfying our goal that your index must be greater than the exponent of your radicand. Now, if you're going to ask me why 2 to the 12 and 3 to the 12 becomes 2 times 3, because when you give square root to every exponential expression here, if you have 2 12th root of 2 raised to the power of 12, understandable that we are canceling 12th root and 12, and so what's left will be 2. And so that's why we have here 2. The same thing with 3 raised to the power of 12. And this is now our final answer. Thank you for listening.